Hi everyone, I need you to open up your Algebra 1 enrichment notes to page 13. So your absolute value notes to page 13. Okay, in this video we are going to talk about absolute value inequalities, what they are, and how to solve and graph them. Okay, so this is the only video in this lesson. Okay, before we start the absolute value inequalities, I want you to do the warm-up, okay, in your notes, which is number 1 and 2 at the top of page 13. So go ahead and do the warm-up number 1 and 2. This is practice on solving absolute value equations. So do the warm-up, okay? I want you to pause the video, do the warm-up, and then when you're done, unpause it and check back. Okay, so you should have the warm-up completed. I'm going to write the answers down and just tell you what they are, okay? And then if you don't know how to get them, if you have a question on it, please see me when you come to get your homework and your notes checked for this lesson. So number 1 on the warm-up should be x equals 10 and x equals 2. Number 2 on the warm-up should be x equals 5 and x equals negative 15. So again, check your warm-up, okay? If you're not sure of something, please ask me when you come show me your notes, okay, and show me your video. All right, let's actually go on page 13 of your notes. Let's go right down to the box. Let me explain this first, and then we'll go back to the 2 problems. So solving absolute value inequalities, we're going to fill in this chart and talk about this. So if we have the inequality, AX, the absolute value of AX plus B is less than C. That's the form that any absolute value equation had to be in. Well, that form goes the same way for absolute value inequalities. C has to be greater than 0, okay? Now, if it's an absolute value inequality and it has less than, okay, it's the same thing as an and compound inequality, okay? I know we haven't gotten to these compound inequalities yet, but I'm going to explain this to you today. Since it's a compound inequality of and, okay, it looks like this. You should have a negative C and a positive C. Just like we do equations, we get rid of this absolute value symbol, we drop this C down, and we make the C over here negative. Anytime you see the sign or the inequality sign for less than, I actually want you to say it like this. Less than. If it's a compound inequality and the symbol is less than or equal to, I want you to say it as less than. The reason is it's an and compound inequality. Okay, and I'll show you what the graph looks like in a little bit here. So less than, we are changing to less than. It's an and compound inequality. So the second pull, it says the inequality, the absolute value of AX plus B greater than C, where C is greater than 0, is equivalent to the compound inequality AX plus B less than. So we got rid of the absolute value sign. We flipped the inequality sign to less than, okay? So this one is going to be negative C. And then this one over here, we have AX plus B, so no absolute value. It's still greater than, and this one is C. So greater than is an or compound inequality. So I want you to write down greater instead of greater than, okay? It's an or compound inequality if it's greater than or equal to. When you split this one up, one of them you rewrite just as it appears here, but without an absolute value sign. So still greater than, and just put the C there. The other one over here, you rewrite it without the absolute value sign, but greater than changes to less than, and the C becomes negative. Okay, and the last part here says, in the inequalities above, less than can be the same thing as less than or equal to, and greater than can be the same thing as greater than or equal to. Okay, so again, I know we haven't learned this in regular algebra yet, okay, but I will explain it so you understand what a compound inequality is. Okay, so going with letter A. Okay, letter A, we have less than. We know it's an and compound inequality. So you want to rewrite the x without the absolute value sign. Drop down your less than with the 3. And then on the other side, make another less than symbol. And now that 3 is going to be negative. So basically, we're just doing what that chart told us to do. So it's less than. We know it's an and compound inequality. X has to be between -3 and +3. Okay. Since it's an and compound inequality, if we pick a number like 0, okay, ask yourself, is 0 greater than -3? It is. Is 0 less than 3? It is. So any number in between there has to be true. Since it's an and compound inequality, your graph's going to kind of look like a dumbbell. Okay, so let me show you how to do this on the graph. X greater than -3. Okay, so we're going to have an open circle here because it has to be between these two numbers. Okay, X has to be more, which means larger than -3. X has to be less than 3. So since it's and, any number that falls in between the two open circles is a solution to this inequality. And again, it's an open circle because it's either less than or it's greater than, okay? So any and compound inequality, the graph's going to look like this. Okay, let's go to letter B. Letter B, we have absolute value of x greater than 3. So it's greater. So we know it's going to be an or compound inequality. Okay. Very first thing that we'll do, okay, is we'll drop down the absolute value of x greater than 3 and just rewrite it without the absolute value of symbol. So x greater than 3, or you also rewrite it, okay, rewrite the x without the absolute value symbol, change greater than to less than, and make the 3 negative. So it's the opposite to the problem that we just did. X is greater than 3, or x is less than -3. So remember, -3 always goes to the left because it's smaller than the 3. So let's plot these on the number line. This is telling us any number greater than 3 or less than 3 is true on this number line. So let's plot x is greater than 3 first. X greater than 3, you have an open circle above 3 because that's telling us any number larger than 3 is a solution. So open circle above 3, arrow going to the right. X less than 3, open circle above -3 because it can't be -3, it has to be less than that. And the arrow is going to the left because any number less than -3 is a solution. An or compound inequality is always going to have the arrows going in opposite directions. So let's pick a number. If we choose, let's say -5, okay, and we go and plug that in, is the absolute value of -5 greater than 3? Okay, it is because the absolute value of -5 is 5, and it's greater than 3. Okay, let's try another number over here. Let's try 6. Is the absolute value of 6 greater than 3? The absolute value of 6 is 6, and yes, 6 is greater than 3. So again, greater than or equal to is an or compound inequality. The arrows will be going in opposite directions. If it's less than, okay, it's always less than. It's an and compound inequality. The dumbbell's always going to be in the middle. Okay, it's going to be any number in between that is a solution to the inequality. Okay, so those are the basic examples. Let's flip over our note packets, page 14. Let's do a couple more together, and then I'll have you guys try one on your own. Okay. Let's start with, since we already did some basic examples, let's start with letter C. Okay, so letter C in your packet says the absolute value of u is less than 3.5. So since it's less than, we know it's an and compound inequality. So if it's an and compound inequality, we're going to rewrite the inequality as it is, getting rid of the absolute value symbols. Okay, write another less than symbol over here, but now that 3.5 is going to be negative on this side. So we need to graph this or illustrate this on a number line. Negative 3.5 is smaller than 3.5. So negative 3.5 goes further down to the left. Okay. If we graph this, we know u has to be between these two numbers. It has to be greater than negative 3.5, and it has to be less than 3.5. So if it can't be those numbers, we have to have open circles. We know the numbers have to be between. So if we look at just this side, u has to be greater than negative 3.5. It has to go this way. And then this one, u is less than 3.5, goes this way. We know it has to be smaller. If we connect them, that tells us any solution for this inequality is in the middle. The open circles tell us that it cannot be those numbers. So if you just test one, let's say that we tested like number 1, okay? If we plugged 1 back in up here, is the absolute value of 1 less than 3.5? Okay, it is, because the absolute value of 1 is 1. 1 is less than 3.5. Okay, so I hope that one makes sense. Let's go to some of the harder ones, and let's go to letter D. Okay, letter D, we have absolute value of x plus 3 greater than 8. So greater, we know it's going to be an OR problem. So we're going to split this one up because it's already in the form absolute value of something is greater than something. So rewrite it just like it is without the absolute value symbol. So x plus 3 greater than 8. So I'm going to put that one on the right. That one's always going to be the one that's the same, just without the absolute value symbol. And then we're going to write it again on the left, still getting rid of the absolute value symbol, but you change the greater than to less than and the 8 to negative. So the OR one, you have to remember a little bit more when you rewrite it. And also make sure it's always in the form absolute value of something is greater than, less than, whatever your inequality symbol would be, and then a number. At this point, it's very similar to absolute value equations. We just need to solve each of them. So I'm going to start with this one. To get x by itself, we just subtract 3 on both sides. So we have x less than negative 8 minus 3 is negative 11. Or, since it's greater, to move the 3 to the other side on the right one, we subtract 3 on both sides. We get x is greater than 5. So let's plot these on our number line and see what it looks like. Negative 11 is smaller, so that goes further on the left. 5 is bigger, so that goes on the right. X is less than negative 11. We have an open circle above negative 11, arrow going to the left. That tells us any solution further to the left is true. And then x is greater than 5, open circle above 5 because it can't be 5, arrow going to the right. Okay, so if we tested this, let's see if this works. If you plugged 6 in, we have 6 plus 3 is 9. So really that leaves you with, is the absolute value of 9 greater than 8? It is. And if you tried a number down here, let's say negative 12, okay? If you have negative 12 plus 3, you get negative 9. The absolute value of negative 9 is 9. 9 is greater than 8. So again, if you check anything, it has to work. So I would highly recommend that you go back and check to make sure that you solved everything correctly. Okay, let's try letter F together. This one is, of course, is going to be the most difficult or the hardest here. So let's go to letter F, just because it's not in the form that we need it to be in. Okay, so we have 3 absolute value, 5m minus 6 minus 8 less than or equal to 13. All right, so first problem here is that we need to get it into the form absolute value of something is less than or equal to something. Just like when we solved equations, always move this number to the other side first. So add 8 to both sides. We have 3 absolute value of 5m minus 6 less than or equal to 21. Now at this point, to get rid of the 3, remember you do not ever distribute with absolute value. To get rid of the 3, we divide both sides by 3. Do not distribute. Okay, so these cancel. I'm actually going to move down here, guys, so I don't write over the number line. Absolute value of 5m minus 6 less than or equal to 21 divided by 3 is 7. Okay, so it's less than. So since it's less than, we know it's an and compound inequality. Rewrite the 5m minus 6 less than or equal to 7 without the absolute value symbol. And then on the other side, rewrite the less than or equal to again, but then make your c, which is 7 in this case, negative. So rewrite the less than or equal to and make that 7 negative. Okay, now this is something that we haven't done yet in regular algebra, so listen carefully on this part. To solve this, you need to get the variable in the middle by itself. So to solve this, we have to get that m isolated or in the middle all by itself. To move this negative 6 first, you add the 6 to the middle, to the right, and to the left. Just like solving an equation on a compound inequality, what you do to the middle, you have to do to the left and to the right as well. So when we do that, the negative 6 plus 6 cancels, okay? The negative 7 plus 6 is negative 1, okay? So we have negative 1 less than or equal to 5m less than or equal to 7 plus 6 is 13. Now, after you add that 6 to the middle, left, right, we now have a 5 left in the middle. Okay, that 5 left in the middle in front of the m, it's really 5 times m. So the opposite of multiplication is division. To get rid of the 5, and I know this isn't going to be a nice answer, we divide every part by 5. What you do to the middle, you have to do to the left and to the right. So I'm going to rewrite this. We have negative 1/5 less than or equal to m less than or equal to 13/5. So you can change these to decimals if you want at this point. I'm going to leave them as fractions because typically your answers will be written as simplified fractions. Once you decide that you have your and compound inequality, we're going to go up to the number line. Negative 1/5, okay, is smaller, so that goes to the left. So we have negative 1/5 on the left. And then 13/5, of course, is bigger. It's positive. Okay, we know that that's larger. If you change them to decimals, that's fine. So not only does this one have decimals, but it also has the inequality signs are different. We have greater than or equal to and less than or equal to. Okay, all the other problems we've just had either greater than or less than. So if we look at this side, okay, if m is greater than or equal to negative 1.5, greater than or equal to means it can be that number. So you have to have a filled in circle above negative 1/5. Greater than or equal to goes to the right, okay? It can be that number. And then the other one over here, m is less than or equal to 13/5. Filled in circle for less than or equal to because it can be that number. Okay, it goes this way because it's less than or equal to. They connect in the middle because we know it's an and compound inequality. So that was our ultimate answer, the one I just put a box around. Okay. Be careful in a problem like this. Again, either leave them as decimals or leave them as fractions. Pay close attention to what the inequality signs are, whether it's less than or whether it's greater than or equal to, okay, when you go to graph them. Okay, I hope that you guys are getting this and that makes sense. I want you to take a look at letter G, okay? And I want you to do letter G on your own, okay? So circle letter G and letter E. So circle letter G and circle letter E. When you come see me to get your assignment, I want you to show me letter G and E with your work and with your graph, and then I will give you the assignment. And we have one more lesson, which is graphing absolute value functions after this. So see me as soon as you watch this video so you can get your assignment and make sure that you are ready to watch the next video.